We've been using addition and subtraction of polynomials and collecting like terms with our monomials and finding the degree. Now what we're going to do is move into multiplying and also factoring. And we're only going to strictly look at multiplying by monomials. We'll get into something further than that here in just a few videos. But first, the first essential understanding there is that you can use the distributive property to multiply a monomial by a polynomial. So mono, remember, meaning one term may have a coefficient and variables, by a polynomial, which has many terms. Now, distributive property, when you're multiplying with these, you have to keep in mind what your exponent rules are whenever you are multiplying. The same goes, we can actually going to reverse the process, and that is the factoring. It reverses the multiplication. Factoring you can think of as division. Basically, we're going to take out what had originally been put into the parentheses. We're going backwards. We're going to be using the greatest common factor, which you all have been finding GCF for quite some time now throughout the last few years. And you should be able to do this, but one thing again you're going to have to keep in mind is using those exponent rules and what happens with your exponents when multiplying or dividing, which in this case we're calling factoring.
In this problem, you will multiply a monomial and a trinomial. Which polynomial is a simpler form of negative x cubed times the quantity 9 times x to the 4th power minus 2 times x cubed plus 7? Your choices are 4 trinomials. What should you keep in mind when multiplying? Remember to distribute negative x cubed to all of the terms. Also, remember to add the exponents instead of multiplying them.
Okay, so we've talked about distributive property multiple times. You make sure you distribute that all the way through the parenthesis, but then we've also, I just told you to remember your exponent rules. When you're multiplying like bases, okay, you add those exponents, and that's what they reminded you here about. You do not multiply. Now think about your coefficients. We are, in fact, going to be multiplying our coefficients together, but you add your exponents.
Use the distributive property. Multiply negative x cubed by each term of the trinomial.
Now what they're going to do is actually show you what it looks like when you distribute before you actually multiply.
Multiply the coefficients and add the exponents to simplify the polynomial.
Okay, they moved kind of fast, but just to kind of recap what they did. Negative 1 is your coefficient here, times 9 gives you negative 9. Multiply your coefficients. But then your like base is x, so you're going to add those exponents. Again, negative 1 is your coefficient, negative 2 is your other coefficient, so negative 1 times negative 2, that's where the positive 2 came from. And then again, add your exponents. And then last here, you've got negative 1 times 7, which is negative 7. The 7 didn't have an x, so that's why it's still just x to the 3rd. So multiply your coefficients, add your exponents when simplifying.
Now simplify. The correct answer is D.
So distribute your negative x to the 3rd throughout the entire parenthesis, making sure you multiply coefficients, add exponents. That way you can simplify throughout.
Now it's your turn.
All right, so again, we've got a monomial, 5n, that we will be distributing throughout this trinomial. So distribute 5n to each one of these terms within the parenthesis. Now, I'll give you some answer choices to look at. Pause the video because this may take you just a few minutes to answer this. Okay, your answer to this, for this problem, again, make sure that you have multiplied throughout and add your exponents on your like bases. You get 15 n to the fourth minus 5 n to the third plus 40n. And this is what it will look like if you distribute 5n. So each term, each monomial in the trinomial has a 5n, and then you just simplify from there. Multiply coefficients and add exponents. Now, greatest common factor. We're going to be looking for what the largest coefficient is for greatest common factor, the greatest common factor for the coefficients, and then also for our variables, okay? So if I gave you 5, 25, and 45, this is something that you've done in middle school before. 5, 25, and 45. What's the greatest common factor? What is the largest factor that 5, 25, and 45 have in common? And hopefully that's pretty simple for you. It's 5. 5 will divide into each one of these evenly, and that's the largest number that will. Then you also have to consider the greatest common factor of your variables, x cubed, x squared, and just simply your x. So this is what we're going to look at. This is one way you can come up with greatest common factor. List your prime factors, which is something, again, that you've done before, but this is x cubed, so I have x times x times x, x cubed. X times x is x squared. And again, they broke these down into prime numbers, 5 times 5. 45 you could break down into 3 times 3 times 5. Prime numbers, remember prime numbers are only divisible by 1 and themselves. And then, of course, we just have a single x. Now, a lot of times people will not worry about the coefficients here. They can find the greatest common factor, but they will write out the variables. And so just ask yourself, how many x's do all three of these have in common? I'm not asking how many x's do they have together. That would be addition. I would add them all up. I want to know how many do they have in common. This one has 3. This one has 2 x's. And this one has 1. So they only have 1 x in common. Okay? So that leaves this one with 2 x's left over, and this is with 1 x left over. So they only have 1 x in common. So their greatest common factor is 5x. 5 was the largest factor for my coefficients, and x is the only variable that they have in common. Okay? So I want you to try one, finding the greatest common factor. Here's your trinomial. 3, -9, -12, and just focus on 3, 9, and 12. What's the largest number that will divide into all three of those? What's their greatest common factor? And then focus on x to the fourth, x squared, and x to the first. How many x's do they have in common? Not together. How many do they have in common? And then write the GCF. So here's your answer choices. All right, so the solution to this is C. The greatest common factor is 3 for our coefficients, and then they only have 1 x in common. So 3x is the GCF.
In this problem, you will factor out a monomial from a polynomial. What is the factored form of 4 times x to the 5th power minus 24 times x cubed plus 8 times x?
Okay, so remember, factoring is going in reverse. It reverses multiplication. So think about this. Basically, this is what used to be your answer, and now you're giving me the question. Okay, somewhere along the lines, there was a monomial outside of a set of parentheses. Okay, and we distributed in. So now we're going to factor out. We're going to take this out. Basically, we're going to find out what was that monomial that we distributed in to get that trinomial.
To factor the polynomial, first factor each term. Factor 4 times x to the 5th power. Now factor 24 times x cubed.
These are your prime factors, and then however many x's.
And now factor 8 times x. Then find the greatest common factor, or GCF, of the three terms. The GCF is the product of all elements that appear in each of the three terms' factors.
Okay, what they did here is they separated these. They all have 2's in common. This one is the only one that has a 3. And then they all have x's in common. So you got to figure out how many of the 2's and how many of the x's do they actually have in common.
The GCF is 2 times 2 times x, or 4 times x. Why can't another 2 or another x be part of the GCF?
Now this is a good question because this happens a lot when people are trying to solve these, okay? A lot of people want to use all of the 2's. Well, this one only has 2 2's to begin with. It does not share another 2 with the other 2 terms. The 2's and the x's have to be included in all 3 of your terms. Same reason why you can't use a 3. It only appears in one term. It has to appear in all 3 terms in order to be considered part of the greatest common factor.
The GCF needs to be common to all the terms. There is no other 2 in the factors of 4 times x to the 5th power, and there is no other x in the factors of 8 times x. Now factor out the GCF from each term. Then factor it out of the polynomial. Factor out 4 times x from each term in the polynomial.
Okay, just to kind of show you what they're doing because this is a really, really good visual. In 4x to the 5th, in this term, this monomial right here, if I take away what's in red, because what's in red represents my GCF, if I take away both 2's and both x's, the only thing left over out of 4x to the 5th, once I take away those red pieces, is x times x times x times x, which is x to the 4th. So literally, and you can mark these out. If you take out the 2 2's and the x, all you have left over is x to the 4th. Same thing with the next term, negative 24x to the 3rd. That's why there's a negative sign there, because that was originally negative. If you take out the 2 2's and the 1x that's involved with the GCF, the only thing left over is a 2, a 3, and then the 2 x's here. So 2 times 3 is 6, and then x times x is x squared. And again, the negative sign came from the original problem there. The original problem was negative. And then finally with 8x, if you take away each 2, the 2 2's, and you mark out this x, the only thing you have left over there is a 2. So that's why there's a 2 here. Think about this. 4x times 2 gives you 8x. That's that third term. So we're just taking out the GCF from each one of those terms.
Finally, factor out 4 times x from the entire polynomial. The factored form of the polynomial is 4 times x times the quantity x to the 4th power minus 6 times x squared plus 2.
Okay, so they just simply, if you were to distribute this back in, just like the problems we did with like problem number 1, then this is exactly what you would get. So it's a good way to check your answer. But this is factoring. You take all of those 4 x's out. That's originally what was on the outside. And this is the trinomial that was on the inside.
Now it's your turn.
All right, so I want you to factor this. I'm going to give you the answer choices. Please pause the video because this may take you just a little bit. Find the greatest common factor for each one of those monomials. Take that greatest common factor out. That GCF is what's going to be on the outside of your parentheses. So literally take out each one of those pieces from the monomials there. And what you have left over is what will remain in the parentheses after you take out the GCF. All right, your answer to this is C, and I'm going to put the answer page up there. Please pause it to look at it and we'll talk more about this in class.